Hey everybody, so I think this might be our official last day of notes for the 1920 school year of ending in e-learning. So congratulations. I could be wrong, so don't hold me to that, but we're pretty darn close here to the end. So congratulations, you've made it. You've done an outstanding job and I'm super proud of you. So here we go, let's do it. So today we're looking at conditional probability. And conditional probability just simply means that you are looking at things having a condition in place. So what's the probability that it's sunny knowing that it's summertime? Okay, so when you are given a certain situation, it's called limiting your sample space. So remember, sample space is the potential all outcomes. So if you shorten the sample space, you limit the sample space, your probability will change if you are only looking at a certain number. Like, what's the probability of me choosing red if I'm only looking at warm colors? Well, obviously, if I just said, what's the probability of me choosing red from the rainbow is going to be one outcome. But if I said, given I'm only using the warm colors, you've got less to look at. Okay, so that's what conditional probability is. You're putting a condition, you're putting something that limits your sample space. So looking at it today, you've got given events A and B. Your conditional probability is the probability of event B occurring, so the second event, if you want to think about it like that, knowing that event A has already occurred. Okay, so what you're going to see as far as notation goes is you're going to see the big P for probability. I'll let that catch up. And then it's going to be event B. You're going to see a straight up and down line. That straight up and down line implies given. Okay, given event A has already happened. So again, this is read as the probability of event B given A. Okay, so again, that straight up and down line means given. So conditional probability formula, here's how you figure that out. It is the probability of one event given another event happen is found by taking the probability of the given event and the second event, if you want to think about it like that, all over the probability of the given event happening. Okay, so let's take a look at example 1. So Mitchell drew a card from a standard deck of playing cards. What's the probability that he drew a queen? So probability that he drew a queen given, so I want to emphasize that word given, that the card was red. Okay, so in words, what we're looking at, what's the probability that he drew a queen given that the card was red? So that's what we're looking at. Probability of him drawing a queen given that the card is red. So what we're going to do is we're going to look at the probability of it being a red and a queen all over the probability of it being red. Okay, so red and queen. So we're going to look at this. And means multiply. So we have the probability of it being red, which was 26 out of 52, and the probability of it being queen, being a queen, is 4 out of 52, all divided by the probability of it being red, 26 out of 52. So when you end up doing this, this all comes out to be 1 out of 13. Okay, so looking at question number 3, let's look at number 3. There are 62 people that take yoga class and 48 people that take spinning class. 15 people that take yoga also take spinning. And if a person from these groups is selected at random, find the probability that he or she is taking a yoga class. If you know, so that's another way of saying the word given. So we want the probability of them taking yoga given they take spinning. Okay, so that's what we're looking at. So I'm going to do this one in a slightly different way. I'm going to show it to you with a Venn diagram. So what I have is I have my yoga circle. And in total, anyone who's taking yoga is going to be within this circle. And then I have some people, I have my spin circle. And anyone within, and I'm going to highlight it here, anyone in that entire circle, including that overlap space, is going to be taking spinning. And then we've got that overlap, and you know that means they take both. So in total, it says 62 people take yoga. So that means this entire circle there means 62. So in total, the overlap and the not overlap part in total, the two parts that make the circle have to add up to 62. And it says 48 takes spin. And it says 15 people that take yoga also take spin. So there's my overlap. And once I know that overlap, I can start subtracting. So if I take 15 people away from 48, that leaves me with 33. So again, if you added up everything in that spin circle, everything in that highlighted green, it's going to add up to be 48. So I've got that taken care of. So I'm going to erase that outside number. And then I'm going to subtract 15 from 62, and I believe that gives me 47. 47, 15, 52. Yep. Okay, so now I know that there are 47 people who take yoga only, 15 people who take spin and yoga, and 33 people who take spin only. So that's what that Venn diagram says. Okay, so if a person from these group is selected, what's the probability that he or she takes yoga given they take spin? So here's why a Venn diagram is helpful. Remember what I talked about. If you're looking at a given, you are limiting your sample space. So the only people that I am allowed to look at, because of the fact that right there, if we know they take spin, I am only allowed to look at this group of people because I know they have to take spin. Okay, I know they have to take spin. So of those people, so I limited my sample space with that given. Of those people, there are a total of 48 people. And this will actually eliminate your need to use the formula because we've physically, we're just looking at it in a slightly different way. Of those 48 people, look at that Venn diagram. How many also do spin, or I'm sorry, also take yoga? That's where you're going to look at the overlap. Those are the only 15 people in this entire yellow circle that also take yoga. So I would have 15 out of 48, which reduces to 5 out of 16. Okay, so that would be your final probability, that knowing they take spin, what's the probability that they also take yoga? Okay, so next question, it says, of the 30 students in Mrs. Smith's math class, 13 are athlete and 9 are in band. 3 of the athletes are also in band. So I'm gonna, again, do this with a Venn diagram. I have my athletes, I have my band, and I'm going to say, remember, all of those people within that circle are in band, so just watch that. We know that there are a total of 30 students in Mrs. Smith's class, so keep that in mind. It says 13 are athletes, so I know grand total there are 13, and grand total there are 9 in band, but 3 of the athletes are also in band, so there's my overlap, which means 10 are athletes only, 6 are band only. But I want you to look. If 10 are athletes, 3 are athletes who are also in band, that leaves me with 13 students in class. And 6 are only in band. Now I'm at 19 students in class. that leaves me with 11 students that are not in band or an athlete. Okay, they're not in band or an athlete. So we have those outside of the Venn diagram people to take into consideration too. So my question, what they're asking me is, I want to find the probability that the student is in band if it is known, so keyword again there, it's given. So probability that they're in band given they are not an athlete. Okay, not an athlete. So I want to know what the probability is that they are in band, okay, given they are not an athlete. So if we look at this, we have given that they're in band, not an athlete. So the people who we are allowed to look at, if you think about it, we are only allowed to look at our non-athletes. Our non-athletes are these 11 people on the outside. They're not athletes. And we are allowed to look at those 6 band members because they're not athletes. And remember, the given limits your sample space. So if I'm looking at this probability, I only have 17 people who are not athletes in that entire class. So then I want to know, well, how many of those are in band? Well, look inside your Venn diagram at this point. 6 of those 17 people are in band. Okay, so another option that you have is you can create a table with this. Sometimes I think tables are your easiest option. It's just easier to see the sample space that you're limited to. So looking at this, your table, you've got, it has different categories. And so we have 50 randomly selected students who are asked if they prefer to watch hockey or football. Find the probability that, question A, they prefer football given that they are a girl. So if we are given that they are a girl, that means that we are only allowed to look at our girls. Okay, that's limiting your sample space. So of all of our girls, let's add that up. That's going to be 16 plus 6 is 22. So of my 22 girls, how many of them prefer football? Well, 6 of them do. So then I can reduce that to be 3 out of 11. Okay. So then looking at my next question, it says, what's the probability that they are a boy given that they play hockey or prefer hockey? Well, here's my prefer hockey people, all of those people. So those are the only ones that I'm allowed to look at, which is a total of 26. And how many of those are boys? 10 of them are. That reduces to 5 out of 13. So sometimes I think tables are easier to look at because it's just easier to eliminate the things that are not in your sample space that you're allowed to look at. Okay, so let's look through this question. The table shows the results of 150 students. Let's go through this. It says the probability of a 7th grader who takes French. So this is not a given situation. There is no symbol for the given, and there is no words that say it is known, and there also isn't the word given. So we're simply looking at 7th grader and French. So I'm going to look at my French and my 7th graders. Those 25 students fall into both of those categories. They are a 7th grader who takes French. So I would say that my probability is 25 out of the 150 students, as they told me that, so I didn't have to add anything up, which is 1/6. Next question, it says, what's the probability that they are an 8th grader given, do you see that straight up and down line, given that they take Spanish? Well, now I have to limit my sample space. I am only allowed to look at the entire Spanish category, that entire column. So if I add that up, that's going to add up to 68. And I want to know the 8th graders. Well, there are 33 out of those 68 kids that are 8th graders, knowing that they take Spanish. I'm only allowed to look at the Spanish column. So what's the probability that they take French given they're a sixth grader? So again, pay attention to the given part. Given they're a sixth grader means I am only allowed to look at those sixth grade students. So if I add that up, that gets me 42, and 19 of those take French. Next question. What's the probability that they are seventh grader given they take French? Again, given limits your sample space. Therefore, we are only allowed to look at the French students. So if I'm only allowed to look at this French students, how many are seventh graders? 25. And when I added up all of those French students, that was 82. So 25 out of the 82. Okay, so you're kind of starting to see the picture with the givens. You do sometimes need to add your columns or add your rows together, but you are looking at limiting your sample space. Okay, so last thing we're going to quickly talk about here is joint relative frequencies. So frequencies is how many times that it actually happened. And then we can look at the marginal relative and kind of looking at totaling each rows and columns. Okay, so if I am looking at this first example here, I know that this gives me the total number of first class and coach class who checked one bag versus checking two bags. So grand total, people who have, let me think here. If I want to look at joint relative and marginal relative, this second chart that isn't filled in, that's going to actually give you your probabilities in a decimal form. So if we are first class who checked two bags, so I'm going to fill in this box right here. If we are first class who checked two bags, I know that what this means is that I am looking at 16 out of, now I'm going to pay attention to how many people checked two bags. Well, in grand total, there is 68 people who checked two bags. This is 72 people who checked one bag. This is 20 people who checked 0 bags. Now I'm going to do columns. This would be 28 plus 2 is 30 people who flew first class. And then we have 102, 110, 120 who flew coach, for a grand total of, just so we know that there are 150 passengers. So if I'm trying to figure out what the percentage of people who were both first class and checked two bags, that would be 16 out of my 68, which would give me about a 0.1 probability. If I'm doing one bag was 12 out of the 72 who checked one bag, that they're in first class, and 0 would be 2 people out of the 20 who checked 0 bags. And again, I would get those in decimal formats. For coach class, there were 52 out of the 68 people. For 2 bags, 1 bag was 60 out of the 68, and 0 bags was 18 out of the 20. So grand total, this should be looking at your percentages, and you would add them up. We'll look at those a little bit later. So looking at question A, it says, what's the probability that they are a coach class passenger that did not check any bags? So coach class passenger that did not check any bags is actually this 18 people out of the 150 people that were in that are in this data. So you could have looked at the second chart if you finished filling it out, and it would give you that percentage, or you can do this as a ratio at this point, but this is 11.25% of the people. So question B says a first class passenger that checked at least one bag, which means they checked 1 or 2 bags. So we're looking at first class passengers, which would be at least 1 or 2 bags, because at least 1 means 2 is acceptable. So that would be what I highlighted, which would be 28 out of the 150 people, which would end up at about 17.5%. So next question, it says probability that you are in coach class given you checked 1 bag. So that means we are only allowed to look at our 1 checked bag row, and given that I'm in coach class. So that would be 60 out of that 72, which is actually about 83%, 83.33. And last but not least, what's the probability that you checked 2 bags given you're in first class? So we're only allowed to look at your first class people. There are 16 out of 30 who did that, which would give you about 53.3% of your people. So if you want my honest answer, I think it's easier to look at it in frequency rather than trying to fill it out as a decimal first. That makes more sense to me, but some of you guys are okay switching over into that percentage first and then answering your question second. But that's a preference thing, but that would be how you would use frequencies with conditional probability. All right, guys. So thanks again. You guys are doing awesome. Please let me know if you have any questions. Always here for you. Okay? Bye-bye.